I hope my screen is visible, na?
Yes.
Okay. Someone has raised your hand, so yeah. Do you have any questions or? Sunila, who is it? She is raising his hand. Okay, so let's discuss some of the questions from week 5, and today's session will be like quick. I'm trying to do it maybe 1 hour or so. So let's start. So don't waste the delay. So the first question is like so we have a grammar. So they given a grammar like S, given S to S, B to D, D to DC epsilon, and how many non-terminals should be added to convert the CFG to CNF. Okay, so this is the this is the question. This is the question here. So how to solve this question? So first, to do it, so let me first decide. Okay, so is the grammar in CFG or not? So what? Okay. So let me write it here. Okay. Okay, so they are asking to transform from CFG to CNF. So I hope you know both of these things. CFG is like context free grammar and CNF is Chomsky normal. Okay. So what is the syntax for a given CFG? So what is the structure? So it should be from a so I'm just asking this one. So what is the structure of a CNF and all these things? So I hope you know. So I'm not writing it here. So the question is, so given this thing, so how given this grammar, S tends to ASB to give or D tends to DC or epsilon. So how many non-terminals should be added to convert the CFG to CNF? Okay. So let's start. Okay. So the grammar is S tends to ASB, tends to ASB given or D and D to D small c. Now, so if you remember correctly, so what is the formation? What is the like permissible format for CNF? It can be A trans to maybe to non-terminal or A trans to a terminal. So this is the permissible format. So we need to transform our grammar, or we need to transform our context to grammar to this form only. Okay, but if you see the grammar that is given here, if you see the grammar that is given here, the format is not as per the CNF prescribed format. So in the first rule, you can see in the right hand side there are three terminal and non-terminal combinations. So A and B, small b are non-terminals, terminals, and S is a non-terminal. So people keep coming. And similarly, in the second example also, this is D to capital D to small c. So it's a combination of terminal and non-terminal, and it's also going to a epsilon, which is not permissible in the CNF format. So to begin with, we need to first do one thing. So we need to first check, okay, so the first thing, if there is a rule called if the star symbol, so in the given grammar the star symbol is S, and if the star symbol is in the right hand side of any rule, so then we need to change it. Okay, so star symbol cannot be uh, the right hand side of any other rule. Okay, so but if you see here the star symbol is S, but it is in the first rule, in the right hand side of the first rule, so we need to change it first. So let's define another new non-terminal called maybe S dash. Okay, so S dash, and S dash will go to S. Okay, so S dash will go to S, and then write it as it is. So S can be A S B or D, and B can be D small c. This is small c and epsilon. So the first level is okay. So the first thing is that we need to check if the star symbol is in the right hand side of any grammar. So as the S in the right hand side of this the first rule, so then we are rectifying this thing. So we are just changing the star symbol. So we are making a new star symbol which is S dash. Now S dash will go to S, and S will can be now as now S is not the star symbol. Now it can be present in the right hand side of any grammar. So the first stage is okay. Now what is the next step? So this is the first step. So this is the first step from this is the zero state. So this is the grammar they are given. Now this is the first step. Now we need to check, okay, so is there any null production? Is there any null production? So we need to remove those things. So I hope you know how to remove the null production. So but still for the sake of completion I will discuss. So this is the null production, D going to DC or null. Okay, so this is the null production. So we need to remove it. So how to remove this null production? Okay, so yeah, so okay, so I'm just writing it here. So it is S dash transform to the first two are same, so we don't need to change anything. Okay, so S tends to A, S, B, then D. Now D can be the first part is okay, so D small c is okay, but there is a epsilon. So if you so what is the grammar now? D can be D or small c, and D also can be epsilon. So D to small c is a possible production. Okay, because now D can be a null. D can be null. So if you just put the null here, so it will be D to small c. So to remove this thing, so to remove this epsilon thing, we can write it like this. Okay, we can write it like this. So we have removed the null thing. So we are just removing the null thing. So now D can go to DC or C. Okay, so this is the second part. So we are just removing the null thing. So this is the second part. Now what is the next step? Now we need to check, okay, is there any unit production or not? So what is unit production? Unit production basically like from a non-terminal to a non-terminal. Okay, so basically in this form. So to a non-terminal to another non-terminal. Okay, so this is the unit production. So we need to remove this thing. Okay, so let me do it here only. So removing this. Okay, now we are in the step 3. We will remove the unit production. So how will you remove the unit production? So how many unit productions are there? So this is there. So S to D is there. So S to D is there. So S to D, and this S epsilon to S. So there are two unit production. One is S to S, and one is S to D. So we need to take care of this thing. So how will you take care? Just replace. So the last production is okay. So it is d small c to small c. So this is okay. There is no null production. Now, so no unit production. Now the second step is s. So this part is also fine. Now the second part is this d thing. So let's replace this with this. So previously it was s to d. So previously it was s to d. So now I'm just replacing d with d's own rule. Okay, so it will be d small c and small c. Okay, so this is the thing. Now s. Now s dash going to normal s. So this is a previous star symbol. Now we can replace s with this. Similarly, we can replace s with s own rule. So it will be s a b d c small c. So now there is no unit production in the grammar. Okay, so there is no unit production in the grammar. Okay, now the grammar is this is the fourth stage. So there is no unit production. But what is our target? Our target is that like the grammar should be look like A to BC or A to A. So basically a non-terminal can go to two non-terminal or a non-terminal to a terminal. So this is the permissible form for a CNF. Okay, so we need to go to this step. So to go to this step, so first, so let's check what are the rules that are okay. So these rules are okay already. So d to small c, it is okay. So d to small c is okay. This s to small c is okay. But the problematic thing is this one. So these are not in the CNF format. So we need to change. So how to change? Okay, so let's define. So let's define another some rule. So for this small a, small b, small c, let's define like a single rule like this. So capital A can go to small a, capital B can go to small b, and capital C can go to small c. Okay, so this is from a format non-terminal to terminal. So we are adhering with this rule. So with this CNF rule. Okay. Now let's replace as per the new rules. So what will be the S dash? So S dash will be capital A, S, B, and D, and capital C, and small c is okay. Small c is fine. Now S will be, again this will be same, S, B, this D, capital C, small c, and D will be capital D, capital C, small c. So this is the fifth step. Now let's check what are the rules that are okay with this CNF format. Now this is fine, this is fine, this is fine, this is not fine, this is fine, this is fine, this is not fine, this is fine, this is fine. So all these things are okay just for this part, because there are three non-terminal, but the permissible amount is only two non-terminal can be possible in the right hand side. Okay, so let's change it. So let's introduce another variable. Okay, so in this slide there are no space, so I can just write it here. Okay. So we can write it here only. First I need to just let me remove the first thing. So we will have a space. So let me remove the first one. So this is the given thing, so I can remove it. So what we can do is that, like, we can replace. So we can replace for maybe for let's introduce another variable called E. It can go to maybe SB. Okay. so it can go to SB. Okay, so now what will be the rules? So now I am just introducing this new variable as per the CONF format. E go to SB. Now what are the different rules we previously have? So A to B, A to A, B to B, capital C to C. Now S dash will be A E, because like this SB, now SB is E, so I'm just writing A. Okay, and DC is fine, small e is also fine. AS will be again AE, so then DC, then small c, and D will be DC. Now check all the rules in this grammar are as per this CNF format. So each of the non-terminal only go to two non-terminal or a single terminal. Okay, so now all these rules are okay as per this CNF. So now we already transformed this CFG to CNF. Now the question they are asking is that how many non-terminal that we have added. Like, let me check the question. So how many non-terminal should be added? Okay, so how many non-terminal that we have added to transfer this CFG to CNF? So how many non-terminal we have added? So we have added E. I'm just circling this thing. So we have added E, we have added S dash, we have added A, we have added B, and we have added C. So there are total 5 non-terminal added. So I hope it is clear. So first we are adding one. So the steps start with this thing. So first we need to add a special star symbol, because the given grammar, in the given grammar the star symbol appeared in the right hand side also, so which is not permissible. So we are adding extra. So we are modifying the grammar by adding extra star symbol. So this is now the new star symbol S dash, which will go to the previous star symbol, and then the grammar will be as per the previous only. Then we will remove the remove the null productions. Then we will remove the unit productions. Then we will check, okay, so what are the grammar which are as per this rule. So from a non-terminal to two non-terminal, or a non-terminal to a terminal. Then we will just according to that we will introduce new non-terminals and change the grammar. So with this flow, we in this problem we are just adding 5 new non-terminals. So if you have any doubt in this question, you can ask, or else I will move to the next question.
Okay, sir, you can move on.
Okay, thank you. So this is the question. So okay, I hope there are another one question that I have seen. Okay, so there is another question similar to this thing. So the CFG is given, and they are asking, so how many term. So this question is wrong. So it is how many non-terminal should be added to convert the CFG to CNF. So this should be non-terminal, not terminal. So how many non-terminal should be added to convert the CFG to CNF? So you can try it. Like, you can try it here. So let's check. So what is the answer? So it will be a good exercise. So the grammar is S to A. Let me write it somewhere else. I'll forget. S to A. So the grammar is, now we'll do it first. Okay. So it is S to capital A, small c, capital B, small c, and B to small c a epsilon a small b. Okay. Now, okay, so previously what is like what we have done, we introduce a new variable in case where the star symbol already present in the right hand side of another rule. Okay, but in this grammar, so in this grammar the star symbol is s, but this star symbol is s. Okay, what is that? So in this grammar the so in this is s. Now, but this star symbol is like is not anywhere in the right hand side of any other rule. Okay, so this is the only place where you can find this star symbol s. So we don't need to do this procedure. So we don't need to introduce new star symbol. Okay, so because there are no other places where this star symbol present in the right hand side. Okay, so the first step is okay. Now the next step is that we need to remove the null productions. Remove the null productions. Okay. So there okay, so write it here in such a way. So it will be s to a c b small c b to c capital A. So we will not write this epsilon. Now it will just change this thing. So it will be a to, previously it will be a to capital B small c and small b. Now if you just put this b epsilon here, so it can also produce small c. Okay. Similarly, in this s production, if you just put b equal to epsilon, it will can also produce c, but c small c is already there, so we will not change anything. Okay. So now we remove the null production. Now what is the next step? Next step is to check, okay, so what are the rules that already are in the CNF format. So this thing, so before doing so, we need to remove the unit production also. Okay, so let's remove the unit production also. So now what are the unit production? This thing, so s to a is a unit production. So let's remove this. So how will you remove this? Just replace this a with its own rule. Okay, so it will be s to b small c b small c, and we will not write this small c again because we already written this small c, and then b equal to c capital A and a equal to b c small c. Now the unit productions are not there. Now let's check. Okay, so how to change this thing? So okay, so you can see there are such type of grammar. So b small c, small c b small c. Okay, so it's a combination of a terminal and non-terminal. So how to make it two non-terminal? So how to make it two non-terminal? So how to do that? So let's introduce another symbol, maybe capital C, which will produce small c. Now we can write it like this way. So s can be capital B. Now small c. So previously it is small c. So we are just replacing it with capital C. So capital C, small b, small c, capital C, capital B. Now B will be, so capital C, A will be B, capital C, B, C, small c. This is small c. Now let's check what are the rules that already in the CNF form. So this rule is already in the CNF form. This is also in the CNF. This is also in the CNF. This is also. 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 But only these rules only this rule is not adhering with the CNF format. So we need to just change it. So how to change it? So there are 3 non-terminals. So make another introduce another non-terminal which will maybe write it like E. E can be CA. Okay. E can be capital C. Now you just write B as a E, A, and all the others will be same. All the others will be same. Okay. So now all the rules are in the CNF format. So which is A to BC or A to A. So basically A is a like non-terminal. So this is a non-terminal. So both are non-terminals. So those are non-terminals, and this is a terminal. So this is the format. Now all these things are in the CNF format. Now the question is that how many non-terminal we have added to make it CNF. So let's check how many non-terminal we have added. So we have added E. So we have added E and we have added capital C. Okay. Anything else? Anything else? Let me summarize. Let me see. No. Yeah. So only we have added only E and C. So in this question the answer is 2. Okay. So we have added 2 non-terminals. So I hope it is clear. Okay. So if I have any doubt, you can just write it in a comment. So I can see and reply back. Else I will go to the next question. Okay, so I hope there is no further comment. So now let's go to this CKY algorithm to derive the parse tree. So to derive the parse tree. So in the CKY algorithm, what we do is that we will make a table and we'll check. Okay, so is the sentence can be derived from a given grammar. So if someone give you a grammar and a sentence. So what is this thing? So basically, so in the CKY algorithm, what do we do? So given a grammar, G and maybe a sentence. So maybe a sentence S. So maybe a sentence S. You can check is this sentence S can be parsed by this grammar G. So you can check. So is this sentence S can be parsed by this grammar G. Okay. So this is the thing. Now in the question, so they give you a grammar. So they already give you a grammar. Now for the time being, just ignore this thing. So I know you already know this thing. So these are the probability for each of these rules. So you can see. So S can be NN and NN VP, and S also can be VP to NN. But if you know the rules of probability, so from a start node, you only, so the total number of, like, the sum of the probability will be 1. So from S you can go to multiple paths, but all the paths probability should be 1. So you can see here only. So S can be NN VP, this is one of the path, and S can be VP NN, this is another path. So there are only 2 paths. So both of the paths, but the total probability of this thing will be 1. So it is 0.5 plus 0.5, it is 1. So it can be 0.8 and 0.2 also, but the summations of the total probability will be 1. Yeah, so now you can see, so there are you can see the probabilities given, so for all this thing. Okay. Now we can ask so this is there is another rule, so which is NP to NNPB, but there with all probability 0.4, but there are no other NP. Okay, so there may be other NPs possible, but they have not included it. But if they included those rules, total sum of the rules should be 1. Total probability of those rules should be 1. Okay, so just forget all these things. So the thing is that for each of these rules there will be associated probability. Now with this grammar, and so now they are giving you a sentence. So the sentence is children play cricket with friends. Okay, so now they are asking you to derive the past tree of the sentence. So basically we need to like use the algorithm CQY to derive the past. Okay, so given the grammar is given and the sentence is given, now they are asking to use this grammar and use the algorithm to parse the sentence. Okay, so let's do it. So as the sentence is quite big, let's start. I don't know, maybe I cannot finish it, so let's still start. Okay, so let me write it here somewhere, so maybe it will be easy for me to. Okay, so the sentence is children play cricket with friends. So first make a table. So first make a table here. Okay, so I'm just writing it in a small possible way. I hope you have the rules now with you. I know this. Maybe this is in your assignment. This rules, so you can just tally with this. So the question is, children play cricket with friends. So I will not do it fully. I will just show you some of the steps. Then we can write it here also to make it, or you can ignore it. Okay. So there are 5 things. So it is 1. So it is 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. So these are the diagonal elements. So it is 1, 1, 2, 2, 3, 3, 4, 4. Okay, so we'll do it like this way. So we'll first fill up this diagonal element, then we'll go up. Okay. So first fill up this field. So it is like the cell number 1, 1. So the children. So let's see. So what are the production that can go to children? Okay. So if you see in the table, so there is only one production, which is NN2 children. Okay, which is NN2 children with probability 0.15. So I'm just writing it here. So it will be NN. Okay, so just NN. I'm just writing NN. You can write the probability, or you can ignore. So it is 0.15. Now let's play. So if you see the table, I hope you have the table. So if you see the table, so the play can be can go from a VB to play. So there is a rule called VB. Sorry, VB to play. Okay. So there is a rule called VB to play. So it's VB. Okay. So it is VB to play with probability 0.3. Similarly, cricket, you can see. So I hope it is from NN to cricket. from NN to brigade with 0.15. Width is PP, okay, from 0.1, and this friend is NN with 0.2. Is it correct? Friend is, yeah, it is. Now, so all the diagonals are filled up. Now we just move ahead. So now the next step is we need to fill up this thing. So 1 2 1 2 2 3 3 4 and 4. So how I will fill up this thing? So to fill 1 2. So how many different way we can go to 1 2? So it is only one. So this is 1 comma 1 and 2 comma 2. Okay. This is only one. So now we can understand why we are like to implement this CKY algorithm. We need to change the grammar to CNF. So now you can understand why this is the necessity. Because like in the CNF, the only permissible form is to A to BC or A to A. Okay. Now this rule only for this diagonal thing. So this rule only for this diagonal thing, and this rule, this A to BC, are for this the non-diagonals only. Okay. So we can use this is like this way. So 1 1 2 2. So this is from one non-terminal. This is from one non-terminal. So this is that's why to use the CKY algorithm, first we need to change it to a CNF form. Just ignore this. Okay. So to fill this 1 2 cell, so this is one possibility, 1 1 to 2 1 1 2 2, and there is no other possibility. So what is 1 1? 1 is NN and 2 2 is VB. So 2 2 is VB. Now let's check, is there any rule which is like whose right part is NN VB. Okay. So I hope there is a rule which is like VP, I think. Yeah, VP. So NN VB. Okay. So there is a rule called VP. NN VB. NN VB. So the fourth rule. Okay. So the fourth rule. So there is a rule. Okay. So we can write it VP here. Okay. Write it VP. We can also write the probability and all these things. So we can write the VP probability also, which is maybe 0.25. Now let's fill up this cell 2 3. So the only possible way to from 2 3 is 2 2 okay, 3 3. So what is 2 2? 2 2 is VB. 2 2 is VB, and what is 3 3? 3 3 is NN. Now again check in the rule. So is there anything called any rule whose right hand side is VBNN? Okay, VBNN. So I think there is a rule which is also VP. VP is VBNN. 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 Okay. So the third rule. Okay. So you can also write VP here with probability 0.3. Similarly, you can find it 3 4. Okay. Let's do another 2 3, then we will move. So just do it for 3 4. So 3 4 will be 3 3 and 4 4. So what is 3 3? 3 3 is NN. 3 3 is NN, and 4 4 is what is 4 4? 4 4 is PP. And if you check, there are no rules whose right hand side contains this NN and PP. Just check NN and PP. There are no rules whose right hand side NN and PP is there. Okay, NPP is not there. So there are no way to go from like using this thing. We can move it to here because there are no rules for NPP. So we just cross it. Okay, so we cannot go to this thing. So basically we cannot parse this thing. So yeah. So basically yeah. Now go for 4 5, which is 4 4 5 5. So what is 4 4? 4 4 is PP, and what is 5 5? 4 4 is PP, and what is 5 5? 5 5 is NN. 5 5 is NN, yeah. And PPNN, I think PPNN, there is a rule called PB. Let me check. Yeah, PPNN, there is a rule called PB. Okay. So I can write PB. Okay, so we already moved. We already filled this this row, this cells. Now the next step is that another further, one step further. So which is 1 3 2 4 and 3 5. Okay, so we can also do this thing. So let's check. So let's do one step and we'll stop it here. We'll stop for this question. Because this question is big, so there is no point to fill up all the cells. So okay, so let's do this thing. So 1 3. Okay, so 1 3 1. Now how many way you can go to 1 3? There are two possibilities. One is 1 1, then 2 3, or 1 2 3 3. Now check both these ways. So 1 1 is NN, and what is 2 3? 2 3 is BP. Okay. And what is 1 2? 1 2 is BP, and 3 3 is NN. Okay. Now check, is there any rule whose right hand side are this components? So NN BP, NN BP, and BP NN, NN BP and BP NN. So both those are S. So okay. So both these rules boils down to S. So we can write S twice. Basically we can go in 2S. So basically S, S. So there are 2 ways to parse here. So this is this thing. So basically you can now understand why there are two entries here. So this is 1 3. 1 3 is children play cricket. So 1 3 means children play cricket. Now using the grammar, you can parse this sentence, this part of the sentence in a two way. Okay, so you can parse this sentence. So basically this is the thing. So it can be VP NN, it can be NN VP, and from VP there will be, maybe from VP there will be syntax. Let me check. So because like this, so from 1 from 3 so 2 3. Okay, so 2, so 1 2 is VP and VP. Okay, so this is coming from NN VB. This VP also come from VB. Now this N is children, this is play, this is cricket. Similarly, this is children, this is play, this is. So you can see, so there are two ways to parse this part. There are two ways to parse this part. Children play cricket. Okay. So this is 1, 2, 3. So that's why this 1, 3 in the 1, 3 cell we are getting two different star symbols, like two star symbols. So basically it means we can parse this sentence in two different ways. Okay. So similarly you can fill all the other fields. So you can fill this field, this field, this field, this field, this field. So if you can just do it as it is, so as per this thing, so I'm just writing. So for 2, 4 you will not get anything. For 3, 5 you will get VP, also NP. Okay. Then the next step is this thing. So it is 1, 4 and this is 2, 5. So for 1, 4 you will not get anything. For 2, 5 you will get VP, and for the last step, which is 1, 5, you will get S. Okay. You will get S. So in the last cell, which is 1, 5, you are getting S. This means you can parse the whole sentence. You can parse the whole sentence because you are so in the last cell you are getting the star symbol. So this means so you can parse the whole sentence, but there is only one way you can parse the whole sentence. The children play cricket with friends. So the whole part you can parse using just like with just one. There will be just one parse tree for the whole sentence. But if your sentence is like till this thing, so children play cricket, so this part only, then there will be two different ways to parse the sentence. But for the full sentence, there is only one way to parse the whole sentence. So this is the meaning. So if you fill the whole table in your home, so as an exercise, you can find this is the thing. Okay. So now, so this is the thing. Okay. Now in the question, so now we can okay. So they ask you to derive the parse tree also. Okay. So if this is the table, you can also draw the parse tree by just backtracking. Okay. So just backtracking. So how you will get this thing? So then you will go to this that rule, and from that rule you will go to backtrack how you will get that rule. So this is where you can just draw the graph like this. So I'm just doing. I have already done for this small sentence. So in the similar fashion, you can do it for the whole sentence also. Now the next question they are asking is that how many entries are generated while filling the parsing table with CKY algorithm. So how many entries are generated while filling? So in the cell, how many entries are there in the whole table? So if you can see, so there are. So you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Maybe I have. So just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So there are 14 entries. So in the table there are 14 entries. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So there are 14 entries in the whole table. So is this clear? So do you have any question for this table only? Else I will there is a small example. So I will do that like thorough. So then it will be clear. As this is a kind of big example, big sentence. So I'm not filling the whole cell. So someone is raising his hand, so you can ask if you have any question.
Sir, actually, I'm doubting in counting the you are counting it's 14, but I'm not.
Oh, okay. So then how like I'm counting like this. So NN1, VB2. So this is way. So 1, 2, 3, 4, 5. Okay. Then 6, 7, 8. Then here there are 2 A's. So that's why 8 plus 2, 10. Then there are another 2. So there will be 12. Then there is 1, 13. This is 14. So how many non-terminal are there in your whole table? So how
Okay, now clear, sir. Clear. Now I missed the double S and now VPNC. Okay,
yeah,
okay, thank you.
okay. So Pushpa B Patil, you can ask.
Hello, sir.
Yes.
I'm not getting, sir, the path you are saying 1, 1 tends to 1, 1 and 2, 2.
So you are not getting how this 1, 1 cell getting this NN.
NN. I got it, sir. But 1, 1 tends to 1, 1 and then 2, 2 you said like that. That I am not getting. That's, yes, sir. NN, how it is, I am not getting that.
Okay, so I hope there is another small example. So I will I'm doing it thoroughly. So I hope in that example you will like all this doubt will be clarified. If still there will be like if after that the next question you have any further doubt you can ask. Okay, so because this question is big, so that's why maybe you will have some you are having some doubts. But I'm sure that for the after doing the next question it will be easy, because for the next question I will do like the full thing, so from start to end.
Okay.
Okay, so so the next question is like I can do for this example only, but this example is too big, so that's why I'm just ignoring it. So the next question is that the sentence is small, kind of the same question. The question is small. Now they are asking to use the CYK algorithm to find the number of parse trees for the sentence children enjoy music. Okay, so they are asking, so the sentence is children enjoy music, and there may be there may be multiple possible parse trees for the sentence, and they are also asking so to get the probability score for each of the tree. Okay, and yeah, so let me do it for. So I already have written it there. So the grammar rules are same. So you can just look the grammar rule as it is. So this is the grammar. So this is the grammar only. So we are just using this grammar for the new sentence. Okay. So now the sentence is pretty small, so it is manageable for me to do it thoroughly. Okay. So now the sentence is children enjoy music. Okay, children enjoy music. So this is the first place, this is the second, this is the third. Now, so this is the first, second. So we can just ignore this cell. So basically these cells are not for our. So only the upper triangular cells are important. Okay, so this thing. So first we will fill up the diagonal element. So first we will fill up the diagonal element. So 1 1 2 2 and 3 3. So okay, so what is 1 1? 1 1 is children. Okay, so 1 1 is children. Now we need to check in the grammar. So how we can derive this thing? So there is only one rule, which is NN to children with probability 15. Okay, with probability 15. So we can write it as it is. So like we can write it NN to children. Okay. Now next cell is enjoy. Again we can check in this grammar. So it is VB to enjoy with probability 0.2. VB to enjoy. So we can write it here only. So VB to enjoy. Now music. So if you check the grammar, you will find there is a rule which is NN to music. Okay, so we have done the diagonal. So next step is we'll go one step further, which is 1 2 and 2, 3. Now let's check. So 1, 2. Now 1, 2, what you mean by 1, 2? So 1, 2, we can there are one possibility we can derive 1, 2. It is 1, 1 and 2, 2. There are no other possibility that we can derive 1, 2. So basically 1, 2 means children enjoy. So basically 1, 2 means children enjoy. So there are only one possibility. So we can derive children and then derive enjoy. So it's not possible, like there are no other way possible to derive this. It's not possible to derive this children enjoy as a one piece. So we need to break it into two pieces. So it's children and then enjoy. So that's why we can only do it by 1, 1 and 2, 2. So now what is 1, 1? 1, 1, if you check the cell, it is NN. So it is NN. And what is 2, 2? It is VB. Now we need to check. So in the grammar, is there any rule which is NN and VB in the right hand side? So is there any rule whose right hand side contains this NN and VB? And if you see, so there is a rule called VP. There is a rule called VP which goes to NN and VP. So we can just put it here only. So VP goes to NN VB. Okay. Now 2, 3. Now 2, 3. Now similarly 2, 3, there is only one way possible. So it will be 2, 2 and 3, 3. Now what is 2, 2? 2, 2 is VB. And what is 3, 3? It is NN. Now if you check the table, so there is another rule which is VP. VP goes to VB and NN. So you can just write it here only. So VP goes to VB NN. Okay. Now only one cell left, which is 1, 3. Now let's check 1, 3. So what are the possibilities to go for to derive 1, 3? So there are multiple possibilities. So one is 1, 1, then 2, 3, or 1, 2, then 3, 3. Now this 1, 1. So what is 1, 1? 1, 1 is NN. And what is 2, 3? 2, 3 is VP. 2, 3 is VP. Similarly, what is 1, 2? 1, 2 is VP. And what is 3, 3? 3, 3 is NN. Now check in the grammar, is there any rule whose right hand side is this NN VP or VP NN? So you can find there is a rule. So S tends to this, S tends to this. So there are two possibilities. So this will be S, S tends to NN VP or S tends to VP NN. Okay. So because we can reach SS in the two ways. So one is this, one is this. So we are just now we completed the table. Now what is the conclusion? So what conclusion we can make from this table? So one conclusion is that 1, 3. So in the cell 1, 3, as we are getting two star symbol, that means we can parse the whole string in two ways. Okay, so we can parse the whole string in two ways. So what are the ways? I hope now you can understand. So yeah, so let's check. So let's backtrack. Okay, let's backtrack. So this is the first thing. So this is the first thing. So we get a rule which is S tends to the. Let's check the first one. So which is this one. So 1, 3. Let's focus on 1, 3 only. So 1, 3, 1, 3 first one. So and the rule is NN VP. NN. Now this is basically 1, 1. This is 2, 3. So the first rule. Now let's check this 2, 3 part. Now if you go to the 2, 3 here, So you can see there is a rule VB to VB VN. So it will be VB NN. So which is 2, 2 and 3, 3. Now you can see what is 1, 1. 1, 1 is the single sentence, so it is children. What is VB? So what is 2.2? It is enjoy. So 2.2 is that's the second sentence, so it is enjoy. And what is 3, 3 is the last sentence, which is music. So this is one of the parts. So NN, VP, VB, NN. Now let's focus on the next thing. So we can go in this way also. So it is S, comma, VP, NN. So what is VP? It is 1, 2. It is 3, 3. Now what is 1, 2? 1, 2 is NN, VB. NN, VB. And what is this? So basically it is 1, 1. It is 2, 2. Now what is 1, 1? So it is the first character, children. What is VB? It is enjoy. And what is NN? So you can see, so we can parse this string. So the children enjoy music in two different ways. So this is the one way, this is the another way. The first way, the second way. So I hope this is clear, na? If this is clear, then we will calculate the probability for each of these paths. So if you have any doubts, you can ask in this step.
Everything is clear.
Okay. So one of them, in the last question, one ma'am is asking there is some doubt. So now is it clear, ma'am, for after this example? I don't know, maybe he is not listening. Yeah, Pushpa ma'am, you can ask. Yes, Pushpa B Patil, you can ask your questions. You are raising your hand. Is it or?
She is the madam who had that doubt with this variable. Earlier that hand was raised and it remains the same.
Yeah, I think
he hasn't lowered down.
Okay. So let's I hope this part is clear. Now let's calculate the probability for each of these parts. So this thing is again simple. So we just need to calculate in the recursive fashion. Okay. So let's do it for the now this is difficult in the first example. Can I remove this part? Else let me do it here only. There is a small area. So okay. So one. So this is one of the path. So yeah. So this is S. So first check all these different probabilities. Okay. So we know the probability of P11. So the probability of P11 is the simple grammar probability. So this is the from NN to children. So this is the simple probability which is already given in the in here. So it is this thing. So 0.15. Okay. So these things are already given. So it is 0.15. Okay. So basically 0.11 is 0.115. Probability of 22 is what is this? 0.2. Probability of 33. So those are the basic like starting emission probability from a tag to the word. So it is 0.12. Now the question is that how will you calculate the probability for P12. So what is P12? P12 is this thing. VP to NN VP. So to get the probability for this thing, so we need to have the probability. So what is the probability of the rule VP goes to NN VB, then into what is the probability to get which like change NN to like this is the next cell, so it is like NN to 1 1, so it is NN to children into probability of VB to NJ. Okay. So this is how we will calculate the probability for P12. So this thing is already given in the question, and this is also given in the question. This is also given in the question. So you can calculate the P12 this way. So it will be, if you check, so it will be I have written it here. So it will be 0. This is 0.25. This is 0.25. This is basically probability of 1, 1. This is probability of 2, 2. So if you now this became clumsy, so just remove. Okay, so if you do this thing, so it will be P1, 2 will be, if you multiply all this probability, it will be 0.25 into 0.15 into 0.2. It will be roughly 0.0075. Now similarly you can find the probability for P 2, 3. So P2, 3, what is P2, 3? P2, 3 is probability of this rule. So probability of the rule VP goes to VBNN. Then multiply with this thing. So VB goes to some word. So VB goes to the word enjoy into probability of NN goes to the word music. So all these things are given. So you just multiply. So it is 3, 0.2 and 0.12. So which is 0.0072. Now the main thing. So this is the probability of S. So there are two possibilities. You can reach S. So there are two possibilities. So the first possibility is like from the this is, I'm just writing. So this is the first one. This is the second one. So let's calculate the probability of the first part. So first one is S goes to. So what is the probability of this thing? So S goes to NN. So basically it is the probability of. So it is the probability of 1, 3. So this is the probability of 1, 3. So first we need to get the probability P goes to what is the probability of PSS VP into the next step. So from this, so the probability of the next two things. So it is the probability of 1, 1 into VP. So it is probability of 2, 3. So in these things are already calculated. So these 2, 3 are calculated, and these rules are already given. So this is already given. So if you do this thing, it will be 0.5 into 0.15 into 0.0072. It will be around 5.4 into 10 to the power minus 4. And similarly, if you do the next, like the other rule, so the other rule, probability of is given VP NN into probability of 1, 2 and into probability of 3, 3. You just multiply all these things, you will get 4.5 into 10 to the power minus. So then you can, now you will understand. So out of this two derivations, so this two derivation, this has high probability, this has slightly lower probability. So the first one is 5.4 into 10 to the power -4, the second one is 4.5. Now the next question is, what is the total probability of the sentence? So then the total probability of the sentence will be the addition of these two probabilities. So if you just add those two probabilities, you will get the total probabilities will be 9.9 into 10 to the power -4. Is the total probability of the sentence. Yeah. So what is this? Yeah, so your probability score of the most probability we have just got, and then the next question is, using the inside algorithm find the probability. So basically inside algorithm is nothing but this thing. So just there are two paths, we just need to add the so this is. So is there any doubt how I calculate this probabilities? So if you have any doubt, you can ask. I will clarify each and every doubt. So how to calculate the probabilities here for this question. If no, okay, so then let's go to check. Yeah, so now there are another questions. So it is really, the question is easy. The kind of the question is, which are the following? Yeah.
Before we move ahead, based on the same example, when children enjoy music, by using inside algorithm, I'm not able to solve this. Whatever earlier you had explained, I had done that one. But using inside algorithm, I could not solve this example. So could you please take that one?
So basically the inside algorithm, basically this thing only. The outside algorithm is different. Okay, so just hold on. So the inside algorithm is what inside algorithm is saying, ki given a rule, so what is the probability will derive the sentence. So what is the inside algorithm saying? So basically if you can just write the thing, so I'm just writing it. So suppose this is the so just get the intuition of the inside algorithm. I'm not going into the details, so just check it. So the inside.
If I'm not wrong, so here we have calculated the
yeah, this is the same as per this thing.
And just by using two approaches, using NNPT or CPNN. So then if I will do the sum of this one, then what is the final answer I will get? That is 0.45 into 10 raised to -3 plus 0.45 into 10 raised to -3. That becomes 0.99 into 10 raised to -8. That's the correct answer.
Yeah, so that's the correct.
Okay, so just if I will sum these two, then what is the answer I will get? That is the inside algorithm.
Yeah, so basically what is the inside algorithm? So that's why I'm just telling the thing. So what is the inside algorithm? So basically inside algorithm is saying, so this is the formulation, just get the thing. So suppose I'm just writing it with alpha. So this is I. So it is like probability of deriving A from J given the grammar. So this is the thing. So what is this thing? So it is saying ki so the inside probability of A. So suppose this is a tag. So for our case it is alpha. So this is the start symbol and it is 1,3. Okay. So basically if we start with the start symbol S, and we need to generate the thing between 1 and 3. So it is the probability. So given the grammar, it is the probability ki this S string will generate the whole string. So it will generate the whole string. Now there are multiple possible. Now this is the simple general rule. Now for our case, we can derive it in two ways. So we can derive this thing. So there is a one way which this is VPNN way, and this is another way which is S tends to NNVP, or I maybe forget that. So this thing. So that's why we are just summing over to get the inside probability. So basically inside probability is the simple thing. So given a given a rule, given a given a symbol, and this start and end index, what is the given the grammar, what is the probability this start rule will derive the sentence. Okay, so this is how we just make this thing. So this is how we just made this thing. Now as there are two different ways we can derive the S, so that's why we are just adding those two paths. So getting, so in the question you can see, so they are saying ki using inside algorithm find the probability for generating the sentence. So basically one inside algorithm is one path and another inside algorithm is another path. So that's why, so these are two different paths. So but if you go for the outside algorithms, that's the kind of difficult, so kind of tricky thing. But inside algorithm is kind of easy. So given the grammar and this start and end symbol, so what is the probability to get the sentence? So for our case it is like, yeah. So yeah. So for our case, yeah, the inside algorithm. So for this example, it is the start symbol is this S, and the start index is 1 and end index is E. So basically, now we are just we want to know how we can produce this thing. So the children likes whatever this thing given the grammars. So now given the grammar, so now there are two possible ways. So that's why I'm just adding those. Okay, yeah, so now go to this thing. So this is thing, I think it is pretty easy. So which of the following grammars are valid CNF? So as you know, so the CNF structure is like from a non-terminal to two non-terminal, or a non-terminal to a terminal. Now let's check. So then in the first example you will see, so there is in the first option, so it is A to B, so it's not possible. So in the CNF we cannot go from a non-terminal to another non-terminal, single non-terminal, it is not possible. So obviously it is not a valid CNF form. So the next thing is that again, so from a non-terminal, so they are going to three non-terminals, so again this is not valid. In the second thing, yeah, so first in the third option, the first rule is okay, because from a non-terminal we are going to two non-terminal, that is fine. But the second rule you can see, so from a non-terminal you are going to a null production, so it is not permissible in CNF. So that's why it is also not valid. So all these three options are not valid. Okay. So another question is the true and false. So what they are asking, it requires 2n-1 distinct production rules in CNF to generate a string W of length n. Okay, so is it true or false? So it requires 2n-1 distinct production rules in CNF to generate a string W of length. So what is their question? So the question is that, so they are assuming, so assumption is that we have CNF. Now we have a string W which has length n. So basically maybe W1 to Wn. So it's the nth length is n. Now what they are saying, is it like how many steps are required to produce this length? Now they are also saying there will be 2n-1 distinct production rule required. So first check how many distinct production rule we can need to derive a sentence with length n. So what is the form of CNF? So CNF form is A tends to BC, or A tends to a non-terminal. So this is the thing. Okay. Now let's check. So if we just have this rule, So how many non-terminals are there in the right hand side? 2. Okay. So I'm just writing the non-terminals. So we have 2 non-terminals and step is 1 because we are just in the first step. Now let's maybe we are just using again use this kind of rule. We are again using this kind of rule. So then maybe it will be B again BC. So there is no such rule. So I'm just assuming, so there is a rule from one of the non-terminal to another 2 non-terminal. So maybe just we are just replacing it with this. Now how many non-terminals are there? There are 3 non-terminals. And how many steps are there? 2. Again we can do the same thing. We can again replace one of the non-terminal with another 2 non-terminal. So now the non-terminal count is 2, 4, and the steps are 3. So basically, if you just go on such a way, so you will get 2n number of such so n number of such non-terminal. So you will get n number of such non-terminal in n minus 1 steps. So this is correct, is it or not? So you can reach n number of non-terminals using n minus 1 steps. Now in that case, in your string, all will, like in this string, all the n alphabets are non-terminals. So there will be no terminals, but you need terminals to form the string. You need terminals. So you need to replace this thing with corresponding corresponding terminals. So now we have n terminals. So you have n terminals, n non-terminals. So now you need to replace it with you have this kind of rule. From a non-terminal you can produce a terminal. So how many such rules can be you need to use? So we have n non-terminal. So you have n non-terminal. So you need to apply. You need to apply n such rules, n such a tends to a rules to get n terminals. Now you are here. So now you are here. Now you have a string which has n terminals. My n string, so basically n string. So how many steps are there? So you are previously, to get n non-terminal, you are using n minus 1 steps. Now to replace those n non-terminal, you are again using n steps of this from. So total number of steps is 2n minus 1. So this is for generating non-terminal. Now this is for non-terminal to terminal. So there will be 2n minus 1 step by which you can generate a string of length n. Okay. So there are 2n minus 1s. Now the question they are asking, they are saying, okay, so it is fine. So there are 2n minus 1 production rules, but are all these production rules are distinct? No, absolutely not. There is no such constant key all these production will be different. So basically what they are saying key, so this is the thing. So first you have such kind of non-terminal rules. So basically non-terminal 1, non-terminal 2, non-terminal 2, and maybe from a non-terminal I you can generate a terminal j. So this is the general syntax of j. So I can also replace this thing. So it is non-terminal k to non-terminal m, non-terminal n. So this is the general syntax of CNF. This is the general syntax of CNF. So from a non-terminal you can produce two different non-terminal. It can be this can be this m and n can be similar. So basically you can generate two different non-terminals, and from a non-terminal you can generate a terminal. Now using this 2n minus 1 step, one step you can generate a string of this W1 to Wn. So all terminals. All terminals you can generate. So this is fine. But they are asking all is it key all these steps are distinct? No, it's not. It can be distinct or it cannot be distinct. So because like basically if you have such kind of string, so maybe let's take an example. So A goes to BC, BC goes to A, C goes to B, and you need to generate a string called A. Yeah, so maybe you need to so basically this is also A. So you need to generate a string called A. Now how will you do this thing? So basically this is A goes to BC. So this is the step 1. Yeah, and the next step you are just adding 1A and adding 1A. So how many steps are there? This is the first step, this is the second step, this is the start step. So there are total 3 steps. And so basically the number of what is the string count? String count is 2, and we are adding 2 into 2 n minus 1. So this is 4 minus 1. So this is 3 steps. So it is matching. So we can generate a string of length n with 2n minus 1 step. But the problem is that is all the steps are distinct? No. In this example, these steps are distinct because all these rules are distinct. So A to BC is distinct, B to A is distinct, C to A is distinct. Okay. Now suppose my grammar is something like this. So A tends to BB, and we just ignore this. So then what will be the thing? So A will be B will be A, and A will be A. So again we are in the 3-step process, but the rules are like this production rules are not distinct. So first thing is A BB is distinct, B A is also distinct, but B again we are applying BA. So these two are similar. So these two are same. So these steps are not distinct. Okay. So we need 2n minus 1 step, but it may be possible like all these steps are not distinct. So there may be repeated steps, like this example that I have shown here. Okay, so this is this question, and this question is already we have completed. Oh yeah, so okay, so this is for this week. So if you have any question, you can ask. Or yeah, I hope you get this point, na 2n minus 1 thing.
Yes, sir.
Pushpa ma'am is still raising his hand. I don't know. Okay, thank you. Okay, so if you don't have any doubt, then we can stop here and we can again meet next week.
Okay, thank you, sir.
So so I'm just I want to ask you, this is the the way these examples I taught in this here. So is it like understandable, or do I need to change something? I don't know. Like you are saying you will understand, but I don't know is it really helpful or not. So just to make it sure you are getting my this thing, this numericals and all this thing. So if you have any questions, include those examples, then I can try. Or maybe you can ask.
Understandable, sir. Understandable.
Okay. Okay then. Bye. Thank you everyone.
Thank you, sir.
Thank you, sir. Thank you. Thank you.
Bye.